the pineal gland has an important job in helping the hypothalamus to regulate circadian rhythms throughout the body. So I want you to think back to your brain, think back when we learned about the brain and just the layout of things. If you'll remember there are some ventricles in the brain, and sort of right in the center, in the region of the thalamus and the hypothalamus, right in the center of the brain is a ventricle called the third ventricle. And on the roof of the third ventricle is where the pineal gland is located. So pineal gland is, let me get my laser pointer here so we can see together. The pineal gland is right here. So just getting oriented, over here was the pituitary gland. We already talked about that. Here's the thalamus, and this space is the third ventricle that we're mentioning. And right here, this little thing on the back, this is the pineal body. So what the pineal body does is it secretes one hormone that is known as melatonin. You may have heard of melatonin before. Melatonin is interesting because it is secreted when it is dark. You guys get these videos as a one take. There are no redos. So melatonin, let's take a look at how this is produced. All right, so in the eyes, in the retina of the eyes, there is a pigment molecule called melanopsin. And melanopsin is not associated with vision, so in other words, it doesn't have a role in allowing us to see. However, it does provide a nerve input into the hypothalamus. The hypothalamus, in turn, regulates the pineal gland through a nerve connection. So you can see there's a branch that goes down here to the superior cervical ganglion. This is part of the sympathetic nervous system, and then there's a nerve that comes back up and controls secretion of melatonin from the pineal gland. So it ends up being that there is a light dependency in terms of what the pineal gland is doing. And during the daytime, when there is light input into the eyes, production of melatonin is inhibited. Melatonin gets produced at night. It's a hormone that the levels come to a peak in the middle of the night when we should be asleep. And this helps to allow the hypothalamus to control circadian rhythms throughout the body. So what does melatonin do? Where does it bind in the body? When we look for receptors for melatonin, we can find them in a couple of places that we have already learned about. So we were just recently describing the pancreas and what it does in terms of producing insulin. It turns out that the pancreatic islets that we were mentioning, those cells have receptors for melatonin. And so it seems like perhaps melatonin is the means by which insulin levels can be sort of modulated throughout the day. We don't need to be producing a lot of insulin at night. We're not eating at night. So melatonin probably has a role in controlling those sorts of circadian rhythms. It also can bind to smooth muscle in the vasculature throughout the body. So if you'll remember, I think we mentioned this a couple of times before, but things like blood pressure also tend to sort of rise and fall throughout the day cyclically. And so it's probably melatonin that is allowing that circadian rhythm to take place as well. So with regards to people who work night shifts, or perhaps you work a night shift, does that influence melatonin production? It does. I think at this point we're not real clear on what the consequences of that are, but we can measure that melatonin production is modified in people who work night shifts, or just people who travel. If you fly to a different time zone, probably none of us are going to be doing that right now or anytime soon, but when you do travel, melatonin production is altered, and that's because you're in a different time zone, so the light input is different and your body takes a little bit of time for that to adjust. And I think that's where we're going to call it a day on this chapter. So there is a little bit more in the textbook. If you go back to the first video in this segment, or the beginning slides, I had prostaglandins listed in terms of something we were going to talk about in this chapter. Prostaglandins come up in not so much the endocrine system, but rather paracrine and autocrine signaling. These are other ways that cells can message each other over a short distance. So it doesn't really involve circulation through the bloodstream per se. So I think it is okay if we don't include that in this chapter. We're going to be coming to some of the prostaglandins later on when we talk about the digestive system, the reproductive systems. So endocrine functions, I think we've covered the main ones. We will be revisiting the gonads are another major endocrine, have major endocrine roles, but we're going to be covering those anyway when we get to the reproductive chapters. So that is it for right now. I will see you next week. Or rather, you'll see me next week.